Hello folks, you're welcome once again to another fascinating math video. In this video, we're considering problem from analysis. In particular, we'll be looking at a problem from the real analysis. Now, the problem states, let R be the set of all rectangles that have the same perimeter P. Show that the square is the element of R that has the largest area. Then it says, suppose entity is the set of all areas of the rectangles in R. Find the supremum of the set entity. And we know that the supremum of this set is also the least upper bound. The supremum of a set is otherwise called the least upper bound. All right. So we are required in this case to show that the square is the element of R that has the largest area. Thereafter, we are still required to find the supremum of these sets denoted by the symbol entity. All right. Now, how do we go about carrying out the proof? Let's start with the proof part. Before I commence the proof, I would like to introduce to you, or rather remind you, that this platform also offers a private online tutoring. So if you're interested in a private online tutoring, you want your kids, your children to partake in this class, you'll be very free to get across to me. I'm very experienced when it comes to mathematics. I have a degree. I studied mathematics up to the university level, and I've been doing it for quite a while, over 10 years, over a decade now. I've been into the mathematics. All right. So if you're interested in an online private class, you're very free to reach across to me by my email, or you can click the link, my Telegram link, and we have a detailed discussion on how the class should be. All right. So it's left to you. If you're interested, be very free to get across to me, and I'll be very glad to be your online tutor. All right. So here's the problem. Let's carry out the solution of this particular problem. Now we say let R be the set of all rectangles, all right, that have the same perimeter P. Now I want to show that the square is the element of R that has the largest area. Now, what this problem is telling us is saying that square is a kind of rectangle here, and the square is supposed to have the largest area. Of all elements in this set R, the square is supposed to have the largest area. We want to show that. All right, so let's go by the proof. Now, if an element, okay, let's say let X be an element of the set R, all right, such that this symbol means such that X is a square. Why are we doing this? Because we're told from the problem that there is a square. A square is a possible element of the set R, all right? So let S be this scenario. Then we should observe that then the length of X should be equal to writing P over 4. Do you agree with me? Now, this is the reason why I said so. We are told that R is a set of all rectangles that have the same perimeter P, all right? And we know that a square has 4 equal sides. Let me illustrate so you get what I'm talking about. Look at this. We have this as a square, all right? Now, for the perimeter of this square to be P, each length must be P over 4, all right? P over 4. And this also. So when we sum up, we get P as a result. Anything other than this will not give us the result P. And the set R comprises or consists of rectangles that has the perimeter to be P. So if a square is to fall into this set, the perimeter of the square must have a perimeter as P. And for that to happen, each length of the square must be P over 4. All right. So that is the reason why I make this choice. All right. So we can now say, in this case, our length of the square is equal to P over 4. Now we are much aware that the area of a square is equal to length square, and that makes it P over 4 all squared. And that will give us P squared over 16, all right? So you can see that. Now the next we shall consider, let's look at the rectangle. Let's consider the rectangle. So we can say let y this time around be an element of the set arrow, all right? Such that y is a rectangle. We can do that. Then we can call the length of the rectangle, the length of the rectangle, let's call it L1, all right? And breadth of the rectangle, let's call it L2, all right? Now we are much aware that the perimeter P, which is given above in the problem, if you look at the problem, you see that they said that the perimeter of each rectangle is P, which is a constant. Now the perimeter of a rectangle is equals to twice the sum of the length and the breadth, all right? We have this as a result. Now from whence we have this to be equal to P over 2 equals to L1 plus L2. Can you see that? All right. Now on isolating, let's isolate L1. On isolation, we have our L2 now, or rather L1 equals to P over 2 minus L2. Can you see that? All right. Now, we're much aware that the of a rectangle, area of a rectangle is equals to length times breadth, all right? And in this case, our length is already obtained as, what is the length once again? It's L1, all right? And the breadth is L2, all right? Now, we've already made L1 the subject of the formula in this case. So it becomes P over 2 minus L2 multiplying L2. Can you see what I'm doing? Then on expansion, we have the result to be P L2 over 2 minus L2 squared. All right? Now, since P is a constant, the only thing allowed to vary here is the breadth, which is L2. L2 is the variable. So I can say that the area of the rectangle is a function of the breadth. Can you see that? And this allows us to carry out calculus in this problem. All right? Now, since we have to show that the square has the maximum or largest area, if we can show that the maximum area of a rectangle is that of the square, we have succeeded in the requirements. All right? Now, don't forget that this is the area of the square. This over here, let's asterisk it, let's call it star. That's the area of the square. All right? So if we can show that the maximum area of a rectangle is that of the square, we've answered the question. That means the maximum area in the set arrow is the area of the square we've already calculated above over here. Look at it, star. All right. So let's go back to establish that. So in this case, we shall differentiate. All right. So on differentiation, we have that dA by the L2 rather, which can be written as dA or dF of L2 by dA, L2 rather, is equals to writing. Now, on differentiating the first term over here, we are left with P over 2. On differentiating the second term, we are left with 2L2, all right? Now, at stationary points, the derivative, okay, before we do that, let us test for the second derivative. Now, if we differentiate this the second time, we shall have the 2A by the L2 squared to be equal to minus 2, which is less than 0. And this indicates a stationary point, which is a maximum point. All right, that is, this implies a stationary point which is a maximum point. All right, so we have this as a result. So in order to find these maximum points, we set the value of dA by dL2 to be 0, because at maximum points, at any stationary point or critical point, the derivative is always 0. So therefore, now I can say at stationary points, dA by dL2 is 0. All right. So in that case, we set this expression over here to be 0. So we have P over 2 minus 2L sub 2 equals to 0. All right. From whence we have L sub 2 equals P over 4. Can you see that? All right. So we now have the length of the rectangle to be the length of the square above. All right. Now let's look for the breadth. Now to get the breadth, okay, we don't even need to get the breadth. Let's look for the maximum area. Now we'll put this value of this length into the function. Look at the function over here. Can you see that? To see the area. All right. So in that case, area of rectangle, the maximum area of rectangle, which is A max, which is equals to F of L2, and now that L2 is obtained to be P over 4, which is F of P over 4, is equal to writing the function is P multiplied P over 4 over 2 minus P over 4 all squared. Can you see that? All right. So we now have this to be equal to P squared over 8 minus P squared over 16, which can also be written as 2P squared over 16 minus P squared over 16. On subtraction, we have the result as P squared over 16. All right. Our page is exhausted. And this is equal to writing the area of the square, which is in star. You remember that? Let's go over there. Look at it in star. Can you see this? So that means the maximum area of a rectangle, which is the A max over here, of the rectangle is equal to the area of a square. So indeed, the area of a square is the maximum area as supposed in the question, and this is the proof of it. All right, so we're done with this particular problem. What we want to do now, we want to go over to the next. The next say let's the symbol entity, suppose the symbol entity, that is, I mean this symbol over here. All right, this symbol, can you see that? I mean this symbol. Now, well, suppose that the symbol entity is a set of all areas. This time around, we are not dealing with the rectangles, or rather, we are dealing with the areas, that is numbers. It's a set of all areas of the rectangles in the set arrow. Find the supremum, that is the least upper bound of that entity. All right. So how do we get the least upper bound? Now, let me take more page because our page is exhausted. All right. So if we are to find the least upper bound of that set, that implies that the set is bounded. Otherwise, there's no way we would have found the least upper bound. If you are required to find the least upper bound, it implies the set is bounded. All right, it's bounded above rather, not bounded. Or bounded is a different concept from bounded above, and we also have bounded below. All right, we'll not be giving detailed or explanation of concept because this is solving a particular problem. But I've told you already that if you're interested in an online private tutoring, be very free to get across to me. In that class, we shall be looking exclusively into terms in analysis for consigned students, all right? And there are students that are consigned. Also analysis, algebra, and deep trigonometry, and so on and so forth, all right? We'll be looking at problems in details. Also, you can visit my Telegram group where some concepts are explained in quite detail, all right? So let's continue the problem. Now we can say, in this case, we now have all right, since this is an area and this is the maximum area, look at it over here. Let me change to my pen now. Since this is the maximum area we have established, we can say let's say P be an element of this set called entity. All right. Then we are aware that then we are aware that P is less than equal to P squared over 16. Why? Because we have established this to be the maximum area. All right. And that is the maximum area. Now, and since P squared over 16 is an element of this set entity, all right, it follows that the supremum of the set arrow, let me use this painting so that is equal to P squared over 16. And this is the answer. Very, very easy. This is the supremum and at the same time the maximum element of the set, sorry, not arrow, the set entity. I'll put entity over here. Now take note, there's a difference between maximum element of a set and supremum. And there's a difference between minimum element of a set and greatest lower bound or infimum. These concepts are quite different, though they agree at some point, but in detail or strictly speaking, they are different. So when we'll be looking at analysis in details, we shall discuss these terms. These terms are frequent in analysis. When discussing analysis, these terms, you will always use them. All right. So we're done with this particular video. Just take your time, go through the problem once, twice, and thrice if possible to get a full grasp of what I've explained. It's not difficult at all. If you take your time to actually peruse through, you'll discover that the problem is very easy. All right. So have a good day. I really appreciate your time. Thank you very much. I will see you another time.